I will give it Cornell note style, but you put it in there. Those are your notes. You do it how you want. Pythagorean theorem states this: in a right triangle, the sum of the square of the legs is equal to the square of the hypotenuse. And what I mean by legs and hypotenuse is given some arbitrary right triangle. I'm going to just draw this up at the top. There's my right angle. Across from the right angle, this largest side we call the hypotenuse. These two sides over here that form an L, they're called legs. That's convenient. Legs form an L. Leg, not two, leg. Leg, leg. The legs form an L. The legs form a right angle. Now, we are going to call, in this, we're about to get an equation for the Pythagorean theorem. This is you probably have heard this equation before. A squared plus B squared equals C squared. The A and the B are the legs. And it doesn't matter which one you call which one. The C is the hypotenuse. I don't know why I put a parentheses around those. Really wasn't necessary. Leg, leg, hypotenuse. Forgive me. Why does it not matter? I said I wasn't going to. It does not matter which one you call A and B because addition is commutative. We can rearrange those. It does matter which one you call the hypotenuse. Okay? How are we going to use this Pythagorean theorem? Using the Pythagorean theorem. Step 1, identify the hypotenuse. Remembering it will be C in the Pythagorean theorem, in the equation associated with the Pythagorean theorem. Step 2, sub values into that equation, into A squared plus B squared equals C squared. Step 3, solve. And whenever we're solving, eventually we're going to be taking a square root. Step 3, check for reasonableness. Step 4, sorry. Step 3 and Step 3. Again, Mr. Richmond has trouble with numbers. Step 4, check for reasonableness. Put your pencil down when you're caught up. Go, baby blue. Example. Example number 1. These will all be right triangles. So right triangles, they have an L essentially for where the legs meet. This indicates a right angle. Let's say that this side over here is length 4. This side over here is length 3. And we're seeking this side over here, question mark. All right. Step 1. Identify the hypotenuse. What I mean by that is not find what the value of it is, just locate it. Is it what we're looking for, or is it one of the things we know? To identify the hypotenuse, just get on your right angle and draw yourself a little arrow from your right angle. The hypotenuse is across from the right angle. It'll always be the biggest side. A big angle makes a big side. A medium-sized angle will make the medium-sized side. A little angle makes a little side. That makes sense. The more the angle opens up, the bigger the side across from it. So in this case, the hypotenuse is question mark. Question mark is the hypotenuse. And the hypotenuse is C in that statement. Are y'all with me? All right. Step 2. Sub the values into a squared plus b squared equals c squared. Well, I'm going to start with my c squared part. That's what I don't know. It's question mark. I could leave it as c if I wanted to. The 3 and the 4 are a and b. Hello? You looking for Miss Oliver? No, ma'am. He would be right now, I believe, in Miss Buckland's, which would 129 would be the first door on your right. No problem. Probably should have written, forgive me, a squared plus b squared equals c squared. A was 3, b was 4, c, the hypotenuse, is what we don't know. Okay? All right, step 3, solve. So, what is 3 squared?
9.
What's 4 squared?
16.
And I don't know the question mark. That's what I'm looking for. But I can add together 9 and 16. What's that? So I have 25 is the question mark. So I want to solve for question mark. I need to undo squaring. And we talked about this last year in Algebra 1. The undo of squaring is the square root. It looks like this. And normally I would put my square root symbol right here, but I just want to show what's happening to both sides. Whatever I do to one side, I do to the other. Anthony, just like divide is the inverse of multiply and subtract is the inverse of add, the square root is the inverse of the square function. So on the right-hand side, the square root cancels the square, leaving only question mark. Now, technically, you may remember from last year, the square root of 25 is both positive 5 and negative 5. 5 times 5 is 25, negative 5 times negative 5 is 25. But in this case, we will only consider the positive because we're dealing with the length of a triangle, and the length of the triangle would be a positive value. Okay? We think the answer is 5. Step 4, is that reasonable answer? Good, yes, it is. 2 things I mean by reasonable. Is the hypotenuse still the biggest side? Is hypotenuse largest? Yep. Check. 5 is bigger than 3 and 4, isn't it? The other thing about reasonableness, do the two little sides, when added together, are they greater than the big side? Is A plus B greater than C? This is true in all triangles, not just right triangles. If you add the two little sides of a triangle together, it must be bigger than the big side. Consider this. If you had some side of length 5, and then you had another side of length 1, and another side of, say, length 2, those would never touch because this is 5 apart. The 1 and the 2, they would never touch each other. Are y'all with me? When you have a triangle, the two little sides, Hannah, added together are always bigger than the big side. So, in this case, what's 3 plus 4?
7.
Is that greater than 5?
Yep.
So, it passes our two reasonableness checks. So, it's very possible this could be good. And of course, we could substitute it back into our equation to see, is this a true last thing? Does 3 squared plus 4 squared equal 5 squared? Yep, it does. That's 9, that's 16, that's 25. It satisfies the equation. We didn't make a mistake in our math. Questions? All right, let's do one more example. Just to show y'all I'm not making something up and it's just works in special cases. I'm going to let y'all choose my numbers here. Adrian, pick me a length for this side over here. 8. All right. If that's 8, Fred, how much about would this one? If this one's 8, how much about would that one be?
4.
That's reasonable. Y'all agree with that?
Mm-hmm.
Looks like that's probably about half as much. Okay, we're going to find this side over here. All right. Jalea, what was step 1 again? Okay, so looking at my triangle there, which one is the hypotenuse? 8 is the hypotenuse. Anthony, how did Jalea know 8 was the hypotenuse?
Because it's across the right.
Very good. Just get on the right angle, draw yourself a little arrow. It will point to the hypotenuse. 8 is the hypotenuse. And in our equation, the hypotenuse is C. So this time, we're not looking for the hypotenuse, we know it. Okay? Step 2, we're going to sub into A squared plus B squared equals C squared. All right. Well, we know C. C is 8. That's going there. 4 is either A or B. Does it matter which one?
Nope.
No, because addition is commutative. Order doesn't matter. I'm going to call it A. B is my question mark. I'm going to leave it as B this time. I could call it question mark, but I could also leave it as B. It's an arbitrary variable. Is everybody okay how we got from this line to this line?
Mm-hmm.
Okay. Step 3, we'll solve. I need to square 4. Anybody?
16.
B is what I'm seeking. I need to square 8.
64.
Thank you. I'm solving for B squared. Tristasia, I want to get B by itself. What should I do next? Genius. Is everybody okay with subtracting 16 on both sides?
Yep.
Okay. Left-hand side, Ava? Is everybody okay with that? 64 minus 16 is 48. Now, I want to solve for B. Very good. Taking the square root of both sides. Again, I would normally just write that right here, but I want to emphasize what's going on. I'm going to just I'm just adding another line so you can see clearly what's happening. Is everybody okay with that? Square root of 48, it's not a perfect square. You can estimate what it's close to. Hopefully, we had this last year in our algebra notebook. We had a list of the perfect squares. Go ahead and not right now, but sometime in your algebra notebook, put it at the very back, a list of the perfect squares. I'm going to we know 1 goes with 1, 2 goes with 4. I'm going to skip on down. 6 goes with 36. 7 goes with 49. 8 squared is 64. So, square root of 48 is about what?
5.
One more time, Ava. 6 something almost 7. How does she know that? Well, 7 squared is 49. Can you see 48 would be wedged in right here? Isn't 48 real close to 49? So there is some number over here squared that gives that. It would be remarkably close to 7. It's going to be like 6.9-ish or so. Okay? How are we going to write this? Well, there's a couple ways. First of all, you could totally leave it as the square root of 48. We call this the exact answer. It's like pi. It's a irrational number. It's a non-repeating, non-terminating decimal. We could approximate it using our calculator. One of you knuckleheads use your phone calculator. You can just Google it. What is the square root of 48? It's going to be about 6.9. 6.8-ish. Talon? If you turn your phone sideways, you will often get more things on it.
6.92820.
Okay, so we could leave it as the square root of 48. We can leave it at 6.92. We also need to be able to simplify this radical expression. Hopefully you remember this from last year. You take what's the underneath number called? Starts with an R? Good. One time. Radicand. You break the radicand up into factors. 2 things multiplied together, where one of them is a perfect square. 48 is 3 times 16. Are y'all with me? We can now take the square root of 16. What's the square root of 16?
4.
The 4 comes out, the 3 stays in. 4 square roots of 3 is exactly the same as square root of 48, just like 3 over 6 is exactly the same as 1/2. Okay? So these are just 2 different ways to write it. And we could also write it as 6.92. What are your questions? Put your pencil down when you're ready. Oh, I didn't do the step 4. What's step 4? Reasonableness. When you're considering a reasonableness, you want to consider this approximated number because it's a little more meaningful to us than 4 square roots of 3. So I'm going to come over here with 6.92. Is the hypotenuse still the biggest?
Mm-hmm.
When we add the 2 legs together, is it bigger hypotenuse? 4 and 7 is 11. It's reasonable. Okay? We could substitute it back into C, but it's gonna be okay. All right. Distance formula. The distance formula says this, that distance is equal to the square root of x sub 2, subscript 2, minus x sub 1 squared plus y sub 2 minus y sub 1 quantity squared, where x1 comma y1 and x2 comma y2 are points. You might be thinking, Mr. Richmond, what in the wide world of sports does that have to do with the Pythagorean theorem? Why are we looking at those two together? Point slope form. Okay. Talon has remembered point slope form, and we did some subtracting of x's and y's. When we found the slope, we subtracted. We found that we changed in x. This, in fact, is that same thing, Talon. This is a change in x. Y'all may remember we used the Greek letter delta. I could write this as change in. This is just another form. You don't have to. This is extra information. Change in x squared. Change in y squared. Okay, that's just another form. Extra information. Y'all remember that when we found the slope, we found the change in y over the change in x? Very similar computation here. All right, here's how this relates to the Pythagorean theorem. Okay, just draw yourself an arbitrary x and y plane. Let's plot a point. 5. I think if you go out about 6, you're going to be okay. And let's go up about 6. All right. Let's plot our first point at 1, 2. That's 1, 2. I'm writing it over here just to get it out of the way. And let's plot another point at 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. That point's at 1, 2. That one's at 4, 6. And I want to find this distance here. Boop, 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 boop. I want to find that distance. What is that? Question mark. Well, one thing I could do is I could turn that joker into a right triangle. Can't you imagine like that being the hypotenuse of a right triangle I have not drawn yet? So I'm going to come in here and I'm just going to draw. I'm going to make this into a, I go some amount right and I go some amount up. Well, this horizontal distance here, it's the change in x. We went from 1 to 4. How much is it from 1 to 4?
3.
That's 3 units right there. Is everybody with me? Okay. In our y, we went from 2 to 6.
4.
That's 4. And I could have counted on my thing if I would have drawn it better or had a nice grid paper. Is everybody with me?
Yes, sir.
Now I could use my Pythagorean theorem to find question mark. I won't do it because we've already done this one. One side's 3, one side's 4. Let's look at example number 1. Where'd it go? More up. You just know everything, don't you, Anthony? You're right. Y'all see 3, 4, 5? That is the basic right triangle. It's called a Pythagorean triple, and that's the first one. That's like Pythagoras' baby. That's the first one he discovered. Okay? 3, 4, 5. You need to remember that. Not only is 3, 4, 5 a right triangle, but every multiple, Jalea, like 6, 8, 10 if you doubled it. 30, 40, 50 if you 10 times it. 0.3, 0.4, 0.5 if you 0.1 times it. So you could blow that thing up as big as you want or shrink it down as much as you want, and it would still make a right triangle if it's that same 3, 4, 5 proportion. Okay? So we could show the Pythagorean theorem again. I will not. Suffice to say that the hypotenuse is going to be 5. Okay? But I'm going to show now using this formula. Here comes the formula. The formula says the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. This just means subtract my x's. That means subtract my y's. It doesn't matter which one you call first and second. I'm going to call this point my second point, and I'm going to call this point my first point. Okay? Y'all help me out here doing my substitution. I'm calling this point my second point. This kind of makes sense, working from left to right, this being my first point, that being my second point. What would x2 minus x1 be? I want to subtract my x's. What would x2 minus x1 be? Does everybody see that'll be 4 minus 1? That's just subtracting my x. One of my x's was 4. The other x was 1. And we could have did 1 minus 4. It would have been fine. But since we did 4 minus 1, in the y's we must do...
6 minus 2.
That's it. Here I'm going to show. 6 minus 2. That's just my y's. One of the y's was 6. The other y was 2. All right? Okay. From 0 to 5. 0, I have no earthly idea what you're doing. 5, I could teach somebody else. Do y'all see where the numbers came from? Okay, thank y'all very much. All right, now I'm just going to do a little math. What's 4 minus 1?
3.
And that's going to be squared. I'm not going to square it yet. I'm just going to write it like that. 4 minus 1 is 3. We have 3 squared. Plus, what's 6 minus 2?
4.
We have 4 squared, and we're going to take the square root of that. I'm just going to leave it here for a second. 3 squared plus 4 squared, the square root. That is exactly what we did over here. Look, where are we at? Come on now, get there. Look, I'm just going to look at this. If I just left it right here, 3 squared plus 4 squared, if I didn't add, I'm going to take the square root of both sides. I'm going to take the square root of this. I'm going to take the square root of this. Square root of question mark squared is question mark. And I'm just going to leave this as the square root of 3 squared plus 4 squared. It is exactly the same as my distance formula. It's that exact same thing. Okay? So, what you see is this distance formula is just the Pythagorean theorem, just for finding the hypotenuse. And that subtraction is finding some horizontal distance and some vertical distance. So if they give you they say, what are the distance between these 2 points? If they give you grid paper, you can just make it a right triangle and take a look. But if not, you can subtract the x's, subtract the y's, do the squaring, and so forth. So this is 9, and that's 16. 9 and 16 is 25. And the square root of 25 is 5, which we already knew it was going to be. What are your questions? This will help you with 1.1, which should be in your MyHRW. Having said that, MyHRW 1.2, most of y'all finished it. Some of y'all didn't. You didn't submit it. If you didn't submit it, there's a 0 in the grade book right now. You're not stuck with that 0. Just finish the 1.2 and send me an email that says, I finished the 1.2. Hayden, I'll get with you about how to submit on MyHRW, okay? There's just 1 or 2 other of y'all. Just submit it and send me an email. What are your questions about these notes? Okay. Pause the video. How long do y'all think that was?
Like 15 minutes.